how can we make a claim about something, right? If we have two variables, how can we make a claim between these two variables? And there's this arbitrary value called an alpha level. So think of an alpha level as kind of like a bar, right? And then think of the p-value as the thing that like goes up and down. A p-value is how the likelihood of us having a type 1 error. So if the p-value is less than the alpha level, we say there is a significant relationship, and we can say like this cures cancer, right? If the p-value is 0.051, a cutoff, we say, oh no, I'm sorry, this thing doesn't cure cancer. And it sounds arbitrary, doesn't it? Because you go 0.049 versus 0.051, and it is arbitrary. Generally, this is what I'll say. Alpha levels are at 0.05. They don't. You can change it, but it's generally accepted to be 0.05, and I'm assuming that's what you want them to like, if you want. Yeah. 0.05. Yeah, that's just how it's done. Once again, no rhyme or reason to this. It's not even based on any like statistical like theory or anything. It's just 0.05. But you can see embedded into this. What can we see like? Because 0.5 would be 50% chance of making a type 1 error, 50% chance of making a type 2 error. What can we see embedded in science's desire for 0.05, which is a 5% chance of making a type 1 error? What can we see in that? Specifically with what kind of errors they're okay with and what kinds of errors they're not okay with. Yeah, precisely. So pretty much, yeah. Type 1 errors, they don't want type 1 errors, because we want to keep like the academic space in such a way that like we want to publish as close to truth as possible. We can't ever really get the truth, which is why we're always going to have that 0.05, or else we'd go like 0.00, right? But there's always going to be a little bit of variance. We're willing to accept that 5% margin, but we're not willing to accept any more than 5%. And so we're more comfortable with type 2 errors than type 1 errors. Also, real quick, so the alpha level, this is like, think of a percentage, right? So 0.05 is really just 5%, right? So just make sure on a test or anything you don't say 0.5% or 0.05%. A decimal of 0.05 just means 5%. Yep. Okay. So now we're going to get into hypotheses. Let me just check time. Sure, we're good. We're going good. Okay. Hypotheses. So we have an alternative hypothesis and a null hypothesis. This is weird. I don't know why they call it an alternative hypothesis. I've read some stuff online, and they tell me it's an alternative hypothesis because it's an alternative to the null hypothesis. But the alternative hypothesis is just your hypothesis. So we call it an alternative hypothesis, but it's like, we're just going to, I guess, keep going back to this example. This cures cancer, right? That would be your hypothesis. And then your null hypothesis is there is no relationship between this cure and its ability to cause or cure cancer, right? So a key thing to keep in point here is with the null hypothesis, it's not the opposite. Where the opposite would be like this thing cures cancer or this thing causes cancer, something like that. It's just that there is no relationship between the variables. That's what it is. So it's not like the opposite. It's just saying it's kind of like I plead the fifth. Like the null hypothesis is pleading the fifth, essentially. Like I don't have anything. And the alternative hypothesis is making a claim that there is a relationship. Of course, you can have research questions too, and you can have directional hypotheses where it's like one way this thing has a relationship with its ability to like cure or cause cancer, like has a relationship with cancer. There's a lot of different kinds of hypotheses, but for now we're just going over alternative hypotheses, null hypotheses. So this is something that Professor Hatlin and I actually talked about. The textbook is a little bit weird. It tells you to like accept the alternative hypothesis. You don't accept the alternative hypothesis, right? And like, okay, okay. I just want to make sure we're on the same page with that because the textbook says you can. We're not following the textbook, is that? No. Yeah. Okay, so this is just talking about like how you would frame it. So like the textbook says that if there is a statistically significant result, that allows you to say pretty much like the alternative hypothesis is like something that's supported, but you don't say it that way. You don't say accept the alternative hypothesis, you say reject the null hypothesis. These two things, in essence, are saying the same thing. but semantically we're just changing it. Because the null hypothesis says there's no relationship between A and B. And so if we reject the null hypothesis, in essence we're saying there is a relationship between A and B. This also says there is a relationship between A and B, but it's just phrased differently. Does that make sense, everybody?
You're being a little safer in the language that you're
Mm-hmm.
using. Like, rather than saying, this thing that I thought is correct, you're saying, there is enough statistically significant evidence that there is a relationship, and it
Gotcha.
goes along with what I was thinking.
Mm-hmm.
But
Yeah.
you're still kind of giving yourself a little bit of space.
Is that because it's dangerous to make like absolute statements?
Yes.
Yeah.
Yes. There's a thing called Popper's falsifiability principle. It's essentially saying that the difference between science and pseudoscience or fake science is pseudoscience proves things right. Real science proves things wrong. So in this case, reject the null hypothesis, you're proving things wrong. We're more comfortable with that. Accepting the alternative hypothesis, we're not as comfortable with that. And that goes to the other, like, so now if we were to say that, like, there was no statistically significant result, not say that or find that, right? We would say we fail to reject the null hypothesis instead of accept the null hypothesis. It took me like, I was talking to Professor Hotland about this yesterday, it took me like 12 times to like try to like figure this out because I kept messing things up. It's a lot of negatives. Fail to reject the null hypothesis. So there's 3 negatives in here, but essentially what that means is there is no relationship. Alright, fail to reject, essentially, you don't want to think about it this way, but it might be easy for you to think about it this way, at least at this stage. Accept the null hypothesis, reject the null hypothesis, or accept, right? If that makes sense. So